What's up everyone, Mike Clifford again, and I'm excited to share with you what might be my favorite project to date. This time on Industrial Maker, we're creating a Bluetooth speaker with integrated LED matrix, which has a bunch of visualizations, including some that even sync to music. This is also probably the most complex project I've done since it involves a lot of woodworking, electronics, and programming. That said, with a little can-do-itness, I think that anyone could tackle this project, so let's get to it. It started with rough maple, which meant that I needed to mill down the boards, and that's something I haven't done before. So I do have a planer, but I don't have a jointer, so I had to get a little creative with this. I ran everything through the planer first so that the thickness was consistent and both the top and the bottom were parallel. I used the Craig AccuCut track saw attachment, which turns any regular circular saw into a track saw, to cut one side straight. So I had a straight edge then to run against the fence on my table saw so that I could cut the other side straight. And after that, I had 4 pretty much square edges to my board. While I'm cutting down these boards, I just want to remind you quickly, if you like my builds, please click that subscribe button below the video so you get notified about all of my future builds. Now we're going to be basically making a miter box out of these boards to house the speaker. And here's the one area where I think I made a mistake, could have done it differently. I should have used a crosscut sled or something else to do the miter corners. The maple was such a hard wood that using the chop saw style miter saw actually bowed the blade and got it stuck some during the cuts, which then resulted in a slight bow in the middle of the mitered edges, so they didn't quite line up perfectly. It was good enough though, so on we went. Next, I used some pieces of MDF to create spacers to hold the front plate and the back plate of the speaker in place. Before assembling the speaker box, I needed to pre-drill some holes for the electronic components. A lot of the electronics components I used were panel mount threaded components that were designed for use on thin metal or plastic, so I needed to drill an inset for each of them in the front and back panel. Here I'm drilling the holes for the power jack and for the line-in input. So I drilled a 5/8 inch hole in the back and a 1/4 inch hole on the outside of the back panel. I then repeated this process for the metal momentary and latching push buttons that I would use on top of the speaker to control the LED matrix and the overall power for the unit. And I used a 1 3/8 inch Forstner bit for the back, and then on the other side used a 5/8 inch, which matched the 16mm buttons that I used. Next, I went to make the front panel, which I made from 1/2 inch MDF. In retrospect, I might have used 3/4 inch for the front and 1/2 inch for the back instead of 1/2 inch and 1/4 inch for the back. I first marked the center spots for the 3-inch speakers and then drew a square in the middle which would mark the cutout for the LED matrix. I set up a router with a router edge guide and then 2 clamp down guides that I measured so that I could then move the router right around the edges of the square that I'd marked and cut out a really nice square with the inside edges with a nice rounded edge. And I was making 5 of these, so I only had to do this once, and then I used my first face as a template for the other. So that's actually nice. This took a bit of time. I think you could use other processes. You could probably use a jigsaw or any other technique you could for getting a nice even square. Then I moved over to the drill press and used a 3-inch hole saw to cut out the holes for the speakers using the marks that I put on the front of the faceplate. I moved over to the router table to give the front of the speaker holes a nice chamfer and to give a slightly smaller chamfer to the insides of the LED matrix cutout. You want to be careful here if you have back mount speakers like I did, not to make the chamfer too big so that you have trouble drilling your screws into the back of the faceplate. I spray painted the faceplate white, and although I didn't show it, I later went and sprayed on a layer of lacquer outside. I used the tape as a clamp technique to put together my mitered box here. And if you want to know a little bit more about this. Chris Salamone over at Four Eyes Furniture has a really good video on this technique. I also, as you'll see in a minute, used band clamps just to be sure, but I don't really actually think that those were necessary, given that this is not something that's going to be tossed around or to support a lot of weight. While we're watching that, I thought it might be interesting to give a little background on the design process that led to this, which is a bit unusual. This all started when 5 of my friends all called me within about a week's time to tell me they were expecting their first child. And I was trying to think of something that I could make for them that would be a cool gift and also that would be a cool video, to be frank. And I've been doing a lot with LEDs and woodwork and Bluetooth speaker, and it occurred to me that babies are supposed to be neurologically stimulated with audio, good music, and good visual stimulus, and this all helps in their development. And so I thought maybe I'll make a baby neurological development box, or in other words, a Bluetooth speaker with a really cool LED matrix integrated in it. So this was a bit of an unorthodox design process, but I kind of like where it ended up. Back to the build, I sanded everything down and then used water locks to finish. And I've used this in the past in a number of videos, and I really like how it makes the grain pop without being too yellow. I got a lot of comments in my Rings of Saturn LED light video requesting more details on the electronics, so in this project I'm going to try to give a bit more. For the Bluetooth audio part of this build, we're going to use a really nice board that comes with a kit. Really plug and play for the most part. It's a Dayton audio board with 2x15 watts, it's 2-channel amp, and I'll put a link to that in the video description. Now, this board has a lot of inputs, so you can simply plug in the power supply, the speakers. You can wire the positive and negative to a 19.7 volt power supply. I bought an extra plug-and-play line input. So that will take your line input if you don't want to use the Bluetooth, and that's going to plug right into your board here. Due to all the things involved in this, it's longer than my normal build. So why don't we take a quick break and check out a few music reactive modes. And a fireplace mode, and a matrix mode. Back to the build now. I soldered on the positive and negative for the speaker terminals, and I used some heat shrink on spade adapters to connect them to matching spade adapters on the Dayton audio board. I then marked the holes for pre-drilling my speaker holes, which is really important because there wasn't much margin for error with these before bursting through the front. Then use screws to attach them, and these Peerless audio speakers I used have built-in gaskets, so they are self-sealing when you mount them from the back. Next, I used the table saw to cut the LED matrix diffuser from white semi-transparent acrylic, and then used CA glue to attach the acrylic to the MDF front panel. Now I'm going to show the process of making the sealed speaker enclosures here, but I'm not going to really talk about it because I really honestly think this is probably a pretty poor design. They sound pretty good, but I'm sure some of the sound design buffs out there will tell me a lot of things that I didn't do properly, and I'd actually love to hear them because I'm planning another one of these in the future. Now I'm going to show the process of creating a movable LED baffle, which can adjust the distance between the LED matrix and the diffuser using a thumb screw in the back of the speaker. This allows you to move the LED matrix so that you can get a less diffused look where you can see the dots in the LEDs more, or move it back, you get a more diffuse look where all the LEDs blur together and it gets a more art-like appearance that's abstract. And To this baffle, I added some aluminum, probably wasn't necessary, as a heat sink, cut some holes so that heat from the LED could escape a bit, and then used super glue to attach the LED matrix to the baffle. I drilled a mating hole for the 1/4 20 threaded screw in the back plate and tested it, then attached the thumb screw so that it could move the baffle with the LEDs on it. And I'll show you a bit more about that later. Then I used these threaded metal LED push buttons and put them into the top plate. There'll be one to turn the speaker on and off, another that turns the LED matrix on and off only, and another that switches modes on the LEDs. Next, it was time to mount the Dayton audio board on the inside of the speaker box, and I just used a mounting plate that's pre-made by Dayton. You can buy for a couple bucks, and it made this job a lot easier. I then went about the process of soldering and connecting the line-in jack and the female power jack to the holes I cut earlier in the back plate. Before going further with building, I want to take a minute and explain how the Bluetooth speaker fits with the overall electronics of the 5-volt LED matrix and Arduino. So electronically, the trickiest thing about this build was the fact that we had 19.7 volts powering your Bluetooth amplifier and speakers, and you had 5 volts powering your LEDs and your Arduino. We're going to use this handy little step-down power converter. And this is going to take the 19.7 volts coming in from the power supply and step it down to 5 volts for the Arduino. So if you divide it into sort of 2 separate circuits and break it down in that way with your 19.7 volt half and your 5 volt half, it actually isn't too complicated to think about. With that out of the way, let's solder up the 5 volt step down. And then to adjust it to 5 volts, we just use a screw to adjust the output voltage and make sure that it's 5 volts or pretty close to it. So again, this is overkill, but I was really concerned about heat since this is a gift, so I had a 5 volt fan which I wired into the 5 volt side of the power and connected it with CA glue. I then attached the Arduino Mega and step-down converter with plastic standoff screws and CA glue as well. I think the easiest way to understand the electronics on the 5 volt side is with this fritzing diagram. It's fairly simple. It's just an Arduino Mega to control everything, an LED matrix connected to the Arduino Mega, a momentary push button to switch modes, a mic breakout board to detect music and so it can be audio reactive, and all that connected to the output of the step-down converter with an on-off relay so the whole thing can be turned on and off separately from the power for the Bluetooth speaker. That said, it would probably take a whole other video to really dive into this in any more detail and show the process of solder and everything together. So what I was thinking of doing was setting up a YouTube live session as a Q&A to walk through this diagram and talk about how this is set up to do music reactive LED patterns and how this could also be used in other projects. So if you're interested in that, just let me know, and as long as it doesn't look like I'm going to be sitting there hanging out by myself, then I'll set up one of those YouTube live sessions. So to speed things along, I'll just say what you see here with this mess of wires is really just the same thing you see in that diagram, so follow that diagram. Then it was time to close up the speaker and screw the back plate in. And I used some really nice brass screws, which I thought went with the curly maple well and really gave it a nice touch. So we're almost done here, but before we wrap up, I want to come back and show you how that thumb screw works to move the LED matrix forward or away from the diffuser to give it just completely different looks. I was really happy about how this came out. I think it was a really cool feature I hadn't seen anywhere else. So with that, we are pretty much done with the build. For those of you who skip ahead to the end of the video just to see the finished product, we are going to check that out now. But you might want to go back to the middle because we took an interlude and watched the music reactive modes in the middle. But overall, this is a project I was just really excited how it came out. I hope that it comes out well in video, but in person it's just stunning. If you like this, I'd greatly appreciate it if you hit that like button or even hit that subscribe button to find out about my future builds. That's it for now, and I'll see you next time.